Until someone erases it.
And what do you want us to do here?
Find arc length.
No, the other one.
Are we having issue on taking derivatives? Good. Let's take a look at this. So R prime is going to be negative sine t plus cosine t, comma, negative sine t minus cosine t. And arc length from 0 to 2 pi is going to be the square root of negative sine t plus cosine t squared plus negative sine t negative cosine t everything squared dt. All right, 0 to 2 pi. And now what? We have to square, so I'm getting sine squared t minus 2 sine t cosine t plus cosine squared t, and then another one plus sine squared t plus 2 sine t cosine t for the middle term, and then plus cosine squared t dt. Wow. All right, so these guys will drop, and what I can do is I can so what I can do is 0 to 2 pi I have sine t plus another sine t, so that's 2 sine squared t plus 2 cosine squared t dt. We can kick out root 2, right? When you factor 2 and then you kick out as a root 2, you have 0 to 2 pi of just dt, because sine squared plus cosine squared is 1. Square root of 1 is 1, so that's all gone. And what we get is root 2 t from 0 to 2 pi. So that's 2 pi root 2. Are we all agreeing on this? You wanted 14. There's your 14. You're saying one more? 17? Ooh, nice. That one is yeah. You can. (17) 3D. Your R of is given as t 8 sine t 8 cosine t, no coughing, and the t is between 0 and 4 pi. What is this? Nope. What is this? It's not sphere. It's a helix. Which way? So you gave, I heard 3 answers. I hope none of you ever become pilots.
Oh.
Can I? So yeah, that's not in your skill set. Okay. Let's see one more time. So what kind of helix is this? Yes, wrapping around x-axis. Thank you. It can't go up and down. How do you go to the right? Look, my right is relative to the way what I'm facing. Right? My right is your left at the moment. Right? Can you use those? 3D.
less than or equal to t. Yeah, it's t.
It's a t, clearly. If you see, no, just look at it. It's t, see? It's t. That's clearly t. Everyone have 7? I hope not, because that will be wrong answer. It's not 7.
Mine's nowhere closer.
Yeah, exactly.
Yeah. Are you going to tell us what the actual?
I'm actually going to do this.
Okay, incredible.
Yeah. Let's see. So arc length in 3D, we have 0 to 4 pi this time. 0 to 4 pi. This means one full revolution and then another one, right? By the way, 0 to 4 pi measures how much of a spring you get, if that makes sense. So square root of 1 squared plus, oh yeah, I just noticed this, 8 squared is not 16. No. 8 squared is 64. No, I'm just, yeah. Cosine t plus 64. No, I'm not saying he did it. I'm just saying, it's like a foot. I'm sorry? I have to look somewhere. You're convenient. So it's like to the right. You see, it's convenient. 0 to 4 pi. Now I have 1 plus 64, and then over here I have sine squared plus t plus cosine squared t, that's 1. So the square, it's the square root of 65. So we kick the square root of 65 in front. We have integral of dt from 0 to 4 pi, so the answer should be 4 pi root 65. Green? Good. See, I told you 7 was wrong. The second part of this lecture is to do the same thing in polar coordinates. So we have rectangular coordinates, which is the first formula from Calc 2. Then we have the parametric equation, which can serve both worlds. And now we have polar coordinates world. I did mention a few times that if you have issues with either polar coordinates or parametric equations, you should really spend time working on chapter 10 from our textbook. That chapter is introducing basic ideas about parametric and parametric form and polar coordinates. So now we are going to take this one step further, and we are going to recall the conversion between rectangular and polar worlds, and then use the conversion in our parametric equations to come up with the formula for polar coordinates. So it's again, algebraic manipulation for most of the way. Let's take a look first at ingredients that we need. So the x is given as r cosine theta, and y is given as r sine theta, and that's the conversion factor between the two realms. I am also going to now use theta in parametric form. So I have my alpha and beta, which are actually a and like a and b for t. I'm going to use alpha and beta, which are angles for theta. And these I have, if I write it out, I have dx d theta, don't bother, it won't bother you. And then dy d theta squared d theta. So this is just standard parametric form, but now I'm using angle as a parameter rather than t, like time or whatever. So now all I need to do is to figure out what dx d theta is and plug that in, and then figure out what dy d theta is and plug that in, and then shovel through algebra and simplify to get the equation. So we start by realizing that I'm going to write this. R is the function of theta. R is the function of theta. Therefore, both of these are what? When we take derivative, they are?
We need a word bank. What do you want?
You need a word bank.
They are a lot of things.
Anyone else, Thesaurus?
They are a lot of things.
Yeah, you get a multiple choice.
You get a multiple choice.
Wait, what was the question again?
Okay, so R is a function of theta. Therefore, as I am taking the derivative up there to get these, I have to use
Arc sine?
no.
Well, no, because it's only
I give up. Product rule.
Oh.
I know. So, copy the first, derivative of the second, plus copy the second, times derivative of the first, which is just dr d theta. Same for the second one, copy the first derivative of the second, plus copy the second, times derivative of the first. Now put them in the better form, which is dr d theta. So dr d theta of cosine theta minus r sine theta, and over here we have dr d theta sine theta plus r cosine theta. Plug in. So now length, arc length from alpha to beta, because everything is in terms of thetas, and r is actually f of theta, so I can replace that and put f of theta instead of that. So now what do I have? I have a square root of dx d theta is this one on top, so I have dr d theta cosine theta minus r sine theta, all of that squared, plus dr d theta sine theta plus r cosine theta, everything squared, and then d theta. So now I have alpha to beta integral, and now I have to actually expand all of this. And I'm going to have 6 terms, and then 2 of those, which are the middle terms, will happen to be the same with opposite signs. They will cancel. So now as I go over here, I have dr d theta squared cosine squared. So dr d theta squared cosine squared as a square root. And then this square root will continue in the next row. We'll see how far. So now when I multiply these two and do as 2 times, I have minus 2 times r dr d theta cosine theta sine theta, and finally plus r squared sine squared theta. So that's expanding the first one, plus the second one. As I said, the root will continue. We have, I can generate more paper. I can generate more paper to the right, but then when I export with a PDF for notes, it won't do a good job. So I was going to go with a square root to the next. So plus, and I have pretty much the same. Dr d theta squared sine squared theta. Now we have plus 2r dr d theta cosine theta sine theta plus r squared cosine squared theta, and then finally big d theta at the end. These two cancel. So once they cancel, I can pull dr d theta common factor, dr d theta squared, and what's left in the parenthesis is cosine squared theta plus sine squared theta. That's 1. And then plus I can pull out r squared, and that's what's left is again cosine squared theta plus sine squared theta. Everything d theta. So this is simply integral of alpha to beta, and then what you have is the r d theta squared plus r squared d theta. Now, r is function of theta, so I'm going to replace that in to get the formula that we are all looking for. It is f of theta squared plus f prime of theta squared d theta. And that would be the formula.
Yeah.
Of course, it's math. So that will be the polar form of arc length. Now, if you want to calculate the length, the surface, whose derivative is what? Very good.
Zero.
Yes, yes. The derivative of 5 is 0. So now, when I plug everything in the integral, it's even easier. The arc length from 0 to 2 pi, those are the limits on the angle, square root of, I have f theta squared, that's going to be my 5, so that's 25, plus 0, d theta, and answer is clearly 10 pi. Square root of 25 is 5, and then when you integrate 5, you get 5 theta, plug in 2 pi, 5 times 2 pi is 10 pi. And that's actually what we were looking for this circumference. But again, this is not only to compute, to prove the circumference of the circle. You can compute lengths of many polar curves. And they did work on the spiral, as I can see. R equals to theta. So R equals theta creates a spiral, because as theta grows, R grows, and they grow together, and they create a spiral. So you can compute the you can compute that. Now, I just want to talk briefly before we move to something else. Well, we'll do 2 examples from here. If you are still confused on the polar realm, circle can be written as x squared plus y squared equals to 25 in the rectangular units, or it can be simply put as r equals 5 in polar. It's the same picture no matter which way you look at it. But now there are some severe restrictions that you have with the xy rather than polar coordinates. For instance, if I want a quarter of this circle, in polar coordinates, I would have to solve for y, get the plus and minus y, kill the minus side, and then bound the top in a definite, let's say, definite integral if I'm looking for the area. For polar form, I don't have to do any of that. I can just define theta to be between 0 and pi over 2. And you will get quarter circle. And that goes into limits. So for rectangular coordinates, right, so if I want to calculate, let's say, the area of this, I know I'm going from 0 to pi over 2 on the radius because it is what I call a representative pizza slice. Right, that's the d theta. And that d theta is the one that swings starting here across. So what used to be x1 and x2 in your Calculus 1 course, now you have theta which is angle. And angle goes from 0 to 90 degrees or pi over 2. Now we use only radians to calculate math. Degrees are used in engineering to just show off the final product, but you cannot compute mathematical equations with degrees in them. Do we all understand that? Mathematical equations can only be computed with radians. So your integrals are in radians, and all of these things are in radians, and your alpha and beta better be in radians, and in this case they are 0 and pi over 2 radian. So now, if I want to set up, let's say, area over here, I'll have a equals 1/2 integral 0 to pi over 2 of 5, and then squared d theta. So this is going to give me the area of that one piece. It's a very simple calculation. Now let's take a look at the horror of what the rectangular side is going to bring. First off, we have that the y is equal to plus minus square root of 25 minus x squared. Now, plus and minus here, plus is the top half, and minus is the bottom half. So if I want the area using these guys, I have to go the square root of 25 minus x squared, and because I am only using the top, then it's just positive square root. But then this would give me everything, including this piece that I don't want on the top. So now I have to limit my x's between 0 and 5. So by placing the function inside the integral, if you use positive, you're using positive branch, negative uses negative half of the circle, the one below x-axis. Now, how do I deal with the fact that I don't want the whole thing over here, I just want half of it, which is a quarter of a circle? Well, you do that with limits, which is 0 to 5. So one of these will cut it horizontally, one will cut it vertically to actually get. So this is a vertical cut to just have the top half, and then another cut, horizontal cut to do the upper half, and the vertical cut from 0 to 5 to give us just a half of this. So, you know, if you're not used to this, practice a little bit of setting this up. Now, look at the integral on top and look at the integral on the bottom. They have to give you the same answer. How do you solve the one on the bottom? Trig sub. How do you solve one on top? Yeah, just do it. You look at it and you know.
You can pull out the 25.
Right? That's a 25 over 2 exactly, and just times 2, right? So it's a 25 pi over 4. That's all it is. Now, clearly you know that's a quarter of a circle because the area of this thing is 25 pi, right? It's r squared pi, so 25 pi divided by 4. That's what I got when I integrated. This over here also has to give you 25 pi over 4, and it will, but you have to do trig sub, so have fun with it, right? So that's the reason why we are actually learning polar form, because it makes some more annoying things extremely cheap, right, as we move along. So now that we have this length of the curve, let's see if we can find some kind of polar region that you guys could enjoy. A spiral, r equals 2e to the 2 theta. And you are supposed to be on theta in radians between 0 and ln 8. Have fun. All right, so L is integral from 0 to ln 8 square root of 2e to the 2 theta squared plus the derivative, the square of the derivative. The derivative is 4e to the 2 theta everything squared. What happened?
Y'all did the area.
No, I'm glad you're paying attention to the title of the course. I mean, not the course, the lecture. That's fine. But that's good. I mean, it's extra practice. It will come up. So 0 to ln 8. Under the square root, I have 2e to the 4 theta. No, 4. Plus 16e to the 4 theta d theta. 0 to ln 8. This is going to be the square root of 20 e to the 4 theta d theta. Now you can take the square root here. 0 to 8 ln 8. And when you take the square root, you get 2 root 5 e to the 2 theta d theta. Copy the constant 2 root 5, that's the square root of 20. And then the integral will be e to the 2 theta over 2 from 0 to ln 8. Now 2 and 2 will drop, and you have root 5 in parenthesis e to the 2 times ln 8 minus e to the 0. So now 2 jumps in as an exponent, so it becomes ln of 64. So it's root 5. Or maybe I should write it here. Minus 1. And then that's 63 root 5. Are we all green? 63 root 5? So that's the integration part. We will require one more of these and then end the lecture or end the lecture? One more. That was it. That overrides. Now, which one?
What are our number options?
Number options are 31 through 40.
32. Don't do an odd one.
37.
32 was called first. It's a cardioid. R equals 2 minus 2 sine theta. Again, 0 to 2 pi. Let's see your math skills. Gone hiking. Gone camping. Gone. You got money. Gone. Anything.
It's my fault.
It's just so bad. No, it's like where it's just big, it hurts. Burn. I know.
No, this isn't what yeah, come on, you first.
But then you're right, it's like this.
You don't care about
Yeah, just
I've already got my grade about ambitions. Going hours of paperwork. Absolutely.
Is this working on this one?
No. I know that. Yeah, minus 5 minus 8. It's coming from this square root of 5 minus 8 sine theta. It wasn't bad.
It wasn't bad. Five
We're not
or 8
caring.
minus 8. No, it's easy.
I have 5 minus 8 sine theta.
You got from the signing code.
Because I got 4 minus the whole thing. I got 4 minus 8 sine theta plus 4 sine squared theta plus 4 cosine squared theta, and I changed that to 1.
Yeah, well, does that just make
4.
Okay.
Yes, my goodness, thank you.
It gets a little bit nicer. But still, that's not a
Sorry, Ryan. No problem. Thank you for the 5 though?
Yeah.
Okay, but you have root 1 minus sine theta.
Yes. Yeah, I don't know. I'll change something. You picked the problem. Now just
Yeah, I did.
You have to stick with it.
Yeah, everything. That was just confusing.
I ruined the entire class.
I know, I got that.
What happened? Can't integrate?
No.
Uh-oh.
I don't know, actually. It's been like a week, like 2 weeks since the algebra. I got a negative sign. No, but it's not squared. You should have a negative. Where? What do you have now? Well, when we stand together, it was 4 minus 8 sine theta plus 4 sine squared theta plus 4 cosine squared theta. Then make that a 1. I factored out a 4 first, and then I did a 2. I have a 2 square root of 2, then the integration of a negative 2 sine theta. Square root of that. But I know I was saying that.
It's a double A.
I'm not entirely. Can you stop us through your process? I don't know where you got 2 root 2. Oh my god.
Amazing. All over the integral, right? Like it's... Ah, it's fine now. You guys work it out.
There is definitely a way to do this, but I forgot it.
And you can't break it up.
Yeah. Yeah, so then you can factor out 2 again. Yeah. Then yeah, you factor out another cube 2 square root 2. Then the integration of just the negative 2 sine.
I forgot about that.
That's how far I got.
Oh, I get how you got that. Okay. I
I
get how you
just
got
got that out.
that.
But then like I don't know.
Yeah.
Yeah,
You can just separate
it's on both things. So I just imagine if I just take it out to 1 minus sine theta. And then you can plug square root 2 and then you just have 1 minus sine.
We are approximately.
Oh, I'm setting the
closer
1.
to the answer.
That's why I'm doing it wrong. It would be
I have
1
2
minus
square
sine
root
theta.
2 square root 1 minus sine theta.
I got 4 root 1 minus sine theta.
Because
I don't know. I really don't think this is like.
yeah, it's what I've forgotten. I know it is one somewhere.
Yeah.
This is wrong. It's wrong.
But there's like a way of doing these.
No, why not?
I did something yeah, work. Did anyone get this?
Don't just laugh at us.
Would you
He's not just laughing, he's also playing a game.
Oh, okay. Well, then it's alright.
Yeah, not ready.
No, like.
I didn't even have a pie. I know.
All right, let's talk about this.
Give us another 3 minutes.
Another 30 minutes.
3
Okay.
minutes.
Oh, 3 minutes. Sure.
No,
Another 30 minutes.
1 minus.
It's gonna
I got it. I wrote it wrong. Something. Oh, okay. So you're saying
No. What's this? Reducing? No. What do you do there? 2 cosine theta equals what?
I mean, if you got to that point, you can integrate. 2 cosine theta is just a basic.
Oh. It's 2
But
sine theta.
something is wrong.
Something is wrong? This is probably
Yeah,
wrong.
yeah.
What am I doing wrong?
I don't know, I have to do it. 3 minutes is up, so let's see. So length of the curve is 0 to 2 pi. And now I have square root of 2 minus 2 sine theta squared plus negative 2 cosine theta squared d theta. So the integral 0 to 2 pi, now we have to FOIL. That's 4 minus 8 sine theta plus 4 sine squared theta plus 4 cosine squared theta d theta. Now this mess over here will give us 4, because you factor out 4 sine squared plus cosine squared is 1. 1 times 4 is 4. And then plus 4 in the front, I can have integral 0 to 2 pi of 8 minus 8 sine theta d theta. And we can kick out 2 root 2, which is the square root of 8. And we have 0 to 2 pi of square root of 1 minus sine theta d theta.
Is it not solvable?
Did I say anything? No? Okay, good. Now what? What happened? Yeah, we should do some identities. I just have to figure out which one do we use. So 2 root 2 integral 0 to 2 pi. Now, we can use the, oh no, this is a sine. I need a cosine here. The cosine would give us the nice answer. Sine is not giving us nice answer. We have cosine squared theta is 1 plus cosine 2 theta over 2, and sine squared theta is 1 minus cosine 2 theta over 2. So it doesn't, because see this, if this was a sine, if this was cosine, then we would use it. All right, so that's not it. Now we have to, so
you can't transform that sine to a cosine. Isn't like sine is equal to cosine e over 2 minus theta?
yeah, but that changes the argument.
So what? It's still theta.
That's true. Then we can use u sub, but then you can't even use u sub because you don't have another cosine on the outside to use u sub from there. So yeah, let's see what else we can. So what can we multiply into this to make it work? Technically, complete the square to kill the root. So if I multiply by square root of 1 minus sine theta, and don't write any of this down.
Well, what we do 1 plus sine theta, and then you get a difference of perfect squares, then you take the square root.
What happened?
You multiply by 1 plus sine theta over radical 1 plus sine theta, and then you have a difference of perfect squares.
Yeah, I have difference of squares, but I can't take a root of difference of squares because you get a squared minus b squared, and you can't take a square root of that. You can only take a square root of a perfect square, like this, which is the other formula. But that's not going to help us either, because yeah, this is not going to work either. Let's see if we can do any. So how about some cosecant cotangent deal? Yes. That's the way to do it. Yeah, all the time. 100% of the time it works. Right.
So Wolfram, it's saying to apply sine x equals cosine
pi over 2 minus x, and then we're just going to have it until like
But we don't have the sign on the outside for the u sub. All right. Let's see. So sine theta is equal to cosine of pi over 2 minus theta. That's the identity for the. That's the identity. Oh yeah.
I googled it.
That's
It
fine.
said that root 1 minus sine x is cosine x over 2 minus sine x over 2, or in this case theta.
Yeah.
I don't know if that helps.
Well, I mean, it can be done this way. So let's pursue this first. So now what I have here is 1 minus cosine pi over 2 minus theta, d theta. And what we know from our trig identities is that the sine squared, let's put x, sine squared x is equal to 1 minus cosine 2x over 2. This is a formula.
Well, I know that's a formula. It's like weird. You don't have it.
He's just raised.
Not there yet. So 2 root 2
Should we be writing this?
integral.
That's enough.
Nah, I will upload.
That's enough.
So now, as you can see over here, I can solve this for 1 minus cosine 2x and get 2 sine squared x. Now, when you compare this and this, you have the comparison that 2x is equal to pi over 2 minus theta. So x is equal to pi over 4 minus theta over 2. Perfect. So now we plug all of that in. So we have a square root of, and instead of 1 minus this mess, I have 2 times sine squared of pi over 4 minus theta over 2. D theta. There we go, easy. So you were right. What I was thinking is that I'm not going to have another cosine on the end to do the u sub, but the u sub is easy in this case. So yeah. So 2 root 2 integral 0 to 2 pi, take a square root, I have another root 2, and just have a sine of pi over 4 minus theta over 2 d theta. Now root 2 goes outside. Root 2 times root 2 is 2 times 2 is 4. And all we need to do now is integrate this sign. Now the way we are going to do this is we are going to break this into using the sum formula. So sine pi over 4 cosine of theta over 2, and then minus cosine pi over 4 sine theta over 2 d theta. 4 times, we are still now sine pi over 4 is root 2 over 2, and cosine pi over 4 is root 2 over 2. I can factor that out. So factor this out, root 2 over 2, kick it in front of the integral. And all I need to integrate is cosine theta over 2 minus sine theta over 2, which is what you found as the identity. Right? So we eventually had to stumble upon it. So now what we can do here, well, these cancel, so you have 2 root 2, back to that. Integral of cosine of theta over 2. So integral of cosine is sine, so this is going to be 2 sine theta over 2 plus 2 cosine theta over 2 when I integrate from 0 to 2 pi. Kick out 2, we get 4 root 2, and then I have sine of pi plus cosine of pi minus sine of 0, and then minus cosine of 0.
Stop it. What?
You're supposed to do the conjugate what he was saying originally. He found it online.
That's okay. This is done.
What's the other easy? What's the other?
We don't know if there is easy. So sine.
I'm trying to get the answer right.
So sine of pi is 0. Cosine of pi is -1. And then sine of 0 is 0, and cosine of 0 is
No, you guessed it. You just guessed it. You guessed it.
-8√2. I don't like it.
Is that possible for an arithmetic?
I don't like that it's negative.
The answer is 16.
What happened?
The answer is 16.
Well,
Root 16? Oh, answer is just 16 like this.
Why don't you try the conjugate?
We will. Give a second, there is an issue with the sign. Integral of cosine is positive sign. Integral of negative sign is... Guys, you have to be patient with these things. So plug in 2 pi, that cuts it in half. Plug in 2 pi, cuts it in half, and a 0 and a 0. Sine of pi is 0. Cosine of pi is -1. Sine of 0 is 0. And then minus cosine of 0. Cosine of 0 is 1, so it's -1. Calculations are correct, so there might be something else before. Sine squared x is 1, yeah. Cosine 2x over 2. It's probably over here somewhere.
probably. Okay.
So 1 over, so when I move 2 to the other side, and then I compare 1 minus cosine 2x is equal to this. So that's pi over 4 minus theta over 2, yeah. So now plug that in. So 2 root 2, 2 sine squared pi over 4 minus theta. Okay, that's good. So square kills the root, that's a root 2, that's a 4 outside. Now, sine of the first, sine of the second, minus sine of the second, cosine of the first. That's all good. Root 2 over 2 gets factored out. Cosine. I don't know where the mistake is. It's somewhere over here, I don't see it. Mistake is somewhere over here, but I'm not sure where. I know we can't have a negative answer, so I don't know if 16 is correct or not. If you use the software to find the 16, so sure, we can say, okay, it's fine. It should be 16. But I can't find where the mistake is. We all agree up to this point, right?
Yeah.
Yes, so that's 20 plus confirmations that this line is okay. I just checked everything after this line. I can't find where the mistake is. Well,
This is the answer.
well, that won't help me find the mistake.
It simply gets to there and then just by using CAS. And then has, I don't know what CS is, but you know? This is the textbook solution.
Computer assisting, I don't know, something. It's using technology. You see that they get 15.999999, so they call it 16, sure. But see, what makes me love this so much is I know that the answer is wrong, so I just need to find where where this answer is wrong. And I'm trying to trace all the steps. So this 2 goes on the other side. That's the 2. When I compare these guys, I have that 2x must be (2x) is pi over 2 minus theta. X is pi over 4 minus theta over 2. So we replace this with that.
Then you use sine t is equal to 2 sine t half cosine t half. 1 is equal to cosine squared and sine squared.
Yeah.
That's what they separate.
But that's a different approach.
Yeah, that's how they got the 16.
I have to find where a mistake is.
So when you get the 8 minus the 8 sine theta, and take out the 8, so you get 1 minus sine theta.
Yeah.
Change the sine theta into 2 sine of t over 2 cosine of t over 2, and then they change the 1 into cosine squared to sine squared. And then we solve it like that.
Okay, we can try that. I still want to find the mistake though. I'll have to. Okay, I'll work out the other way, and then I'll play with this later tonight. So 0 to 2 pi, we have 2 root 2 in front. We have a square root of 1 minus sine theta d theta. So from here, sine 2x is 2 sine x cosine x, which means that the sine x is 2 sine x over 2 cosine x over 2, and we can write whatever for 1. Nice. So 2 root 2, 0 to 2 pi, instead of 1, we have sine squared, and we can put theta over 2, plus cosine squared theta over 2, and then we have minus over here, we have minus 2 sine theta over 2 cosine theta over 2. So now all of the arguments are theta over 2, so that will collapse into perfect square as sine theta over 2 minus cosine theta over 2, everything squared. And now the square root and square cancel. And we have 2 root 2 times the integral 0 to 2 pi of sine theta over 2 minus cosine theta over 2 d theta. So now 2 root 2, well, weren't, oh, no, it's the same. It's the same step. I had this. All right, let's see integrate again. What's integral of sine? Integral of sine is cosine, right? So this has to be 2 cosine theta over 2. That's the integral. Integral of cosine is negative sine, and you have this negative, so plus 2 sine theta over 2. From 0 to 2 pi. Guys, I have the same. I had it over here. So now you plug in 2 pi. It doesn't matter which way you do it, you get to the same point. So 2 root 2, when you plug in, there is no such thing. You factor out 2, you make this 4.
Isn't that integral of sine sine?
Integral of sine is negative cosine. Integral of cosine is positive sine. So they're both negative. Do I have the same thing over here? Integral of cosine is positive sine. Oh wait, is this sine minus cosine here? Yeah, see, this is sine minus cosine, and over here I have a cosine minus sine. So, okay, whatever. We are going to kick out negative 2 now, and that's a negative right there. And I have to compute cosine theta over 2 plus sine theta over 2 from 0 to 2 pi. There we go. So now negative 4 root 2. I have cosine of pi plus sine of pi minus cosine of 0 minus sine of 0. Nice. Negative 4 root 2. Cosine of pi is negative 1. Sine of pi is 0. Cosine of 0 is 1, so negative 1. And sine of 0 is 0. So that's negative 2. So negative 4 root 2 times negative 2 gives me 8 root 2. And it's positive. But now you say that the answer is 16. Yeah. So where is the root 2 coming from the first time around? Oh yeah, when you take 8 common factor and you kick it out, it becomes root 8, which is 2 root 2. So that root 2 is with us throughout the entire calculation. So this is still off. At least we have the sign right now. It might be meditate on this. I will. Yeah, I'll have to find what went wrong. I mean, this method here is shorter and cleaner.
Should we try the conjugate way?
Conjugate? Sure, why not? I have nowhere to be. I mean, we still have 50 minutes, so right? I mean, 5 minutes left, and then another 45 after that, so that's 50.
What about 11.9? 11.9.
Huh?
Are we doing 11.9?
This is always next day.
Okay.
Are you coming back tomorrow? Because I will.
I actually wasn't planning to come tomorrow, I'm just saying.
All right.
I'm not saying it for me, I'm just saying it. I want to fit it in super time.
Or
Or had to be
2 root 2 integral 0 to 2 pi 1 minus sine theta d theta, and say conjugate, which is square root of 1 plus sine theta 1 plus sine theta. I'm not sure what would that bring, but let's see. 2 root 2 integral 0 to 2 pi, and now we have on top 1 minus, oh my god, this is so easy now. Because look what you get on top. What you get on top is a cosine squared theta in the radical, and then the bottom is still going to have the mess, but we can use u sub because we have the piece on top. Okay, so that's 2 root 2 integral 0 to 2 pi cosine theta d theta divided by 1 plus sine theta. Now, u equals 1 plus sine theta. du is cosine theta d theta. And that gives us 2 root 2 du over root u integral. And now when you plug in 0, you get 1. And when you plug in 2 pi, you get 1. So now I know what the issue is. Because of this, I know what the issue is. The issue is that, you know how when you are dealing with the integrals, when you're dealing with the integrals, area under the curve and a definite integral are not the same concept. If the function dips below x-axis, you have the difference of areas. Well, that's what we are running into here. We cannot integrate 0 to 2 pi in one shot. We actually have to cut it. Yes, we have to cut this and then double what we're doing or whatever way. So that's the reason. See this u substitution over here? If you go from 0 to 2 pi, you plug in 0 here, it kills the sign, your lower limit is 1. When you plug in 2 pi, sine of 2 pi is also 0, and the upper limit is 1. Integration from 1 to 1 is 0. So this is a symmetric, and actually cardioid depends on which way this one is oriented, but cardioid looks like this, and you see it's symmetric, right? Cardioid, like a heart. Now they can be in all flavors, depending on which way this one is rotated, right? So over here, if it's this way, you have a difference between the bottom and the upper part. If you do this, instead of getting the area of the entire thing, you will just get the area of this. On the other one, you get 0. If you're right, so you have to. So, that's awesome. We have different definitions, though. So now we have to actually figure out the graph, which way the cardioid is, and then find. That's not a problem. That's not a problem at all. You can actually use your abacus to graphing abacus. Yeah. First, I have to collect my energy. Give me a second. There you go. 2 hours. Okay. So. Okay. What I'm going to do now is going to use the TI-83, right? Switch it into What happened?
Can I get that on my phone?
That's what kind of phone you have. Oh, no, you can't. You have one. You have the garbage iPhone. Yeah.
I don't know.
That's also garbage iPhone.
I don't know.
All of the technology produced by that company is garbage. Apple, yes, equals garbage.
Yeah.
There we go. See? That's like +5 in the next step.
You're just saying at least I can take a paper without it being like
Yeah.
grainy.
So, Yeah, those of you taking my class for the first time, you have no idea how much disgust I have towards that company. So,
You love?
yeah.
Yeah, I think you love it.
All right. So now, once I switch to this, and everything they stand for and everything they do.
Well, the guy who stood for it died, so there's no standing for it.
What happened?
Somebody does.
No, that's a good thing. It's an extremely good thing. The world has, like, it's him and Hitler, both dead. Good. You don't know who Steve Jobs was. You just have, like, an idea. So, yeah.
Have you had an interaction?
So, yeah. I have no idea. It's like two people that decimated this world. It's him and Hitler, and that's it. Like the rest, fine, leave it alone. All right, so we have this and the graph. Let's see which way. Not a problem at all. We have this one. So this is the cardioid we have on 2 minus sine 2, and I was trying to see. I have to actually zoom in and graph this again. I'm not sure which way it graphed. So when sine is... Okay, so let's see. We have to... So at least I know it's that one. Now let's see which way it graphs so we can cut it. So theta equals 0 in our 2 minus 2 sine theta. When theta is equal to 0, we have 2. It seems that this is the theta equals 0 point. And then theta equal pi over 2 will give us 0, which is this point here. So that's pi over 2. And then theta equals to pi. Theta equals to pi. That's 0, so it's 2, so this is pi. So I need to integrate from pi over 2 to 3 pi over 2, I believe, right? Because that will give me this piece only, and then I can double that. I think. So let me see what is that going to give us here in our calculation. So now, where's my U sub? It will work on all the other ones up there. So now if I'm using this on U sub, I have the limits now. So the new limits, I'm going to kill these, from pi over 2 to 3 pi over 2. Let's see. So when I plug in pi over 2, the lower limit is 2. Because sine of pi over 2 is 1, 1 plus 1 is 2. 3 pi over 2, so there will be a 0 on top. Because 3 pi over 2 gives us negative 1 on a sine, 1 minus 1 is 0. Good. Now we can switch this with a negative 2 root 2, no coughing. And then integral 0 to 2, I have u to the negative 1/2 du. So now I have negative 2 root 2. Integral over here is u to the 1/2 divided by 1/2, which is times 2. Okay, fine. 0 to 2, and I'm going to get a negative answer now. So there is still an issue, but at least it's not as much. We have negative 2 root 2 times 2 root 2. And I'm getting negative 8 for a half, which is times 2 is getting 16. So all I need to do now is to fix the sign, but we are getting 16. Because I used
How are you going to fix it?
Because I used only half from pi over 2 to 3 pi over 2, and I got 8. And I need to double that. So 8 doubled is 16, right? So we have the right number, but it's still wrong sign.
Why'd you put that negative in front of that?
Over here?
Yeah.
Because the limits went 2 to 0 rather than 0 to 2. So you use the theorem to swap that. Now, what else can I do? Well, the easiest way to cheat over here is to go from 3 pi over 2 to go from 3 pi over 2 to pi over 2. Do what? No, it was negative 1/2. I just wrote it this way. Right? It's a negative because it's the denominator.
Yeah, don't we need to switch that sign and just the sign of that function?
No.
Only change the function.
No. Why integrate this is +1. So negative half plus 1 is positive 1/2, right? That's the integration piece. What an awesome problem. Thank you. Yeah. So that's that. So we need over here to change our limits of integration. This is all. Well, my pen is not working now. Great. Do what?
It just works.
Yeah, just give it a second. Need to sink in. So the limits over here, I used pi over 2 to 3 pi over 2. Oh, we can use, how about if we use negative pi over 2 to pi over 2? Would that fix it? Negative pi over 2 to pi over 2. So if I use negative pi over 2, sine, I think that fixes it. So negative pi over 2, which is the bottom one. So negative pi over 2 is going to give us negative 1, and that gives us 0. And the positive pi over 2 gives us 2. There is no need for this minus, 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 and it's 16. There we go. That's, yes. This is awesome exam problem. Yes?
Pi over 2 is bigger than pi over 2?
Yes. So, well, let me just explain a little bit on that. So, on the unit circle, when we start, 0 is always here. So that's 0 radians, so 0 degrees. And then you have your positive pi over 2. And the positive angles always go counterclockwise. Now, if you go clockwise, those are negative angles. So this is negative 90 degrees. So that will be negative pi over 2. So that's what I did here. I used negative pi over 2 as a lower limit. So I started here, and I went through 0 to pi over 2. So the limits are negative pi over 2 to positive pi over 2, which fixed all of the issues, right, in the u substitution and so on. Now, my question is, obviously, as I go back to doing this problem for the very first time, replacing all of the 0 to 2 pi from negative pi over 2 to positive pi over 2, and then doubling the answer. That could fix the original problem that we had for this. So let's say jump in. Where do I want to jump in? Where's the calculation? Right here. So I'm just going to go here and say negative pi over 2 to positive pi over 2, hoping to see over here 16, right, instead of this mess. So now, what do I need to change? All of these guys will be changed, right? All of this and all of this. So this is going to be sine of pi over 4, cosine of pi over 4 for the top limit. Now, negative pi over 4 here, and negative pi over 4 over here. And now we need to compute this. Sine, so all of these are now different. Sine of pi over 4 is root 2 over 2. Cosine of pi over 4 is root 2 over 2. Now, negative sine of pi over 4, negative, sine is odd function, so negative will jump ahead, and we will have another root 2 over 2. Now, cosine doesn't care about its even function, so cosine will be root 2 over 2, and the negative, so minus root 2 over 2. So these ones will cancel, actually. And what I have is 4 root 2 times root 2, which gives me 8, and then double it to 16. So the original problem, the way I did it, works, and also this method. So we found 3 different ways to do the problem, as just the limits were wrong from the beginning, and that's why we couldn't get it. Yes?
How do you know when you change the limits again? Like, how do you know what to change it to?
Well, clearly I don't. until the problem is wrong, right?
Yeah.
So in Calculus 1, it's very easy to spot, because in Calculus 1, you first need to know whether you're looking for the area under the curve or you are looking for the value of the integral. They're not necessarily the same issue, same calculation, because, as I mentioned before, if your function dips below, this is the negative area, this is the positive area, and then you are going to have the difference between them. So you have to be very careful in Calc 1 what the question is. Now, for these guys, immediately when I saw negative 8 root 2, I knew something was wrong. I went 2 or 3 times through calculations, making sure that all of the substitutions were right and everything looked right. I didn't get to examine the limits at that point. If I examined the limits, then I would see that issue is there. It took me all the way to doing this U substitution here, when I've seen that the limits were from 1 to 1. And that's clearly an issue. So stuff like this will happen for trig, because they are periodic functions, right? So if there is 4 periodic functions, you can trace, as you can see, I traced multiple times over this. You can trace, as many times as you want through this function. Every time you do a full trace, it goes from 0 to 2 pi. But then you can draw each segment of this 0 to pi over 2, pi over 2 to pi, and so on. So each segment is independent. You just need to see which way the symmetry goes. And that's another part of you knowing which way this cardioid is turned. Now, you've seen me here. Yes, I did use calculator to, I drew 2 of them and said it's one or the other. And then I used the calculator to see that it's this one. But I actually don't need the calculator to see it's this one, because I just compute the function at 0, pi over 2, pi, 3 pi over 2, and 2 pi, and that will give me, that gives me this, guys. When I computed these 3 points, like this. What's the only way to fit the cardioid through the 3 points that look like that, right? There's only one way you can fit the cardioid, which is this way. If you compute 0, pi over 2, so you have a function. Remember, you don't have a calculator on the exam to do this, right? But if you are computing and the 3 points end up being this way, well, there's only one common sense way in which you must put the cardioid, and so on. So, there are ways in which you can figure out. Now, what is the symmetry, right? The symmetry was negative pi over 2 to pi over 2. Clearly over here you are good to go from 0 to pi, right? Because that gives that, and then double that. So it depends on the picture. It depends on the way the graph, and the graph is going to be one of the cardioids. So I'm going to draw this in notes so you guys have it. Let's put 4 squares. So 4 squares as 2. So this would be the cardioid. Now this is theta equals to 0. This is theta equals to pi over 2. This is theta equals to pi. Theta equals to 3 pi over 2. Now what we used is this node here as negative pi over 2 and this node here as pi over 2 to calculate the length of this line, which turned out to be 8, and then we doubled that 8 into 16 as the answer. So the answer is L equals 16. So need to double. And the answer was L equals to 16 at the end. Yay! Amazing, right? Negative pi over 2, pi over 2, negative pi over 2. I have to fix all of these now. Nope. So go back and well, the computer logged off and I can't log on to this account, so I will never know if they actually gave us limits or not, unless whoever logged on to this account logs back in so I can see in the book. Oh, Jamie. Still got power. Alright, so all of this is now fixed. Thank you. They say nothing. You picked the only problem which did not have limits for integration. Congratulations. This is absolutely amazing. Look at that problem, 32. It's the only problem in the whole branch that had no limits of integration. It was. It's a very good learning experience. So we figured out 3 different ways to do the integral, and then eventually we also figured out the issue with limits. So that was amazing. Now, since this problem didn't go as well as we all would like to, let's pick another one.
No.
I said let's pick another one to have, you know, to double the fun, to, you know. You say 35?
Yeah, 35.
Isn't that the same? Oh, it doesn't have, but it's a cardioid as well.
No, stop it.
And then we can assign, you know, a third of the classroom to do it one way, a third of the classroom to do it the other way, and a third of the classroom to do it the third way, because we did the previous problem 3 different ways. So I did solve 37. You guys want 35 now, or maybe I can just leave it for the exam. It's good.
No.
Everyone wants to do 35 now. I know.
Question: how would you have dropped that part thingy on the board if you didn't have a graph? You did that.
I did that.
You did that.
You get the 3 dots and then you just connect the dots.
It's in the notes.
Here you go. You can try it. You can try it. So what's the length? Not the area. What's the length? This went the long way. So what's the length of the cardioid line? Graph it first by hand, guys. What I need to see is you put 4 dots. No calculators. You need to put 4 dots on the coordinate system, and those 4 dots will either have this type of configuration or this type of configuration. I mean, they can have also, you know, any of these.
But how do we know it's that versus like the loop?
What is the loop?
You know, where like it doesn't like innately like middle, it has like a bit of like a curve.
You mean a spiral?
No.
Like, how do we know it goes to a point and doesn't just kind of curve in and back out?
Yes.
Oh, because, well, those are different again in the formula. Those have a different formula.
But how do we, if we just get the points, how do we know, like, what about the formula tells us that?
Because, well, the points would be different. The points would look like this. So you can go. That's what you're talking about.
Yeah.
Oh, it is?
Oh,
I was thinking
what's
something
the other
different.
one? The other one where it doesn't, where it doesn't.
I was just thinking about just like a nice, like,
Flour. Flour. You can get the flour.
We're not talking about that. No, that's a different thing.
That's a different thing.
So wait, to find.
So thank you. Yes, each one of the shapes has its own formula. The one that you are working on right now, which is 35, you can't see it yet. There it is. It's all set up for you. Is another cardioid, just like the one we did, except it's oriented differently. So let's go. What we're still young.
What's the interval?
It's a good exercise.
Oh man.
Yeah, I know. Well,
Well,
probably
this one gives us
halfway to
something
11.9.
This one gives us
That's where we would be.
No, it doesn't.
This is
If you
another
pick
one that
any other
doesn't give us the
problem.
limit.
They picked the one that doesn't get it.
Wait, why?
This is a different one though.
Yeah, but it's also the only
This one
other
also
one.
doesn't have a limit of
Yes.
integration.
Exactly. This is the only other one that doesn't have limits of integration. So you have to figure it out.
Alright. Okay, you want a curse, I'll put it $1.
You used up $60 in prepaid.
That was you?
Yeah, my bad.
Crystal's not.
That was about 200 meals.
I'm only supporting that.
I think you should sit.
I can't stand this.
Well, you will have
I'm going to jump out of this suicide.
this formula on 0, I will let's see what the dots look like. And then you will get, and then you will see the
Yes, because you only have to use the half of the. You can't use the entire thing.
Yeah.
Are you sure?
Yeah, not if I die first, but.
I don't share. Sorry.
I don't ask. It's a problem. So the first step, let's just figure out the limits of integration, and then the rest should be the same as what we had so far. So I'm going to compute this formula for theta equals 0, which gives me r equals to 4. Theta equals pi over 2, which will give me 8. Theta equals to pi, so for I'm getting again 4. Theta equals 3 pi over 2. 0. Theta equals 2 pi, which is going back, r equals to 4 again. Hi.
Shouldn't it be -4?
Why?
No, 4 minus 4.
4 minus 4 is 0.
No, but for it equals pi.
Theta equals to pi. Sine is negative.
Wait,
Sine of pi is 0, so it's 4. Yep. Sine of pi is 0. Cosine of pi is -1.
Yes.
Sine of pi is 0.
Yes.
So it's 4.
So.
All right, so now let's draw this monstrosity. I'm using 1 square as a unit of 2. So for theta equals 0, r is equal to 4. This is the dot. For theta equals 0. Pi over 2, r is equal to 8. So 2, 4, 6, 8. This is theta is pi over 2. Then pi, we are back to 4. 3 pi over 2 is going to give me 0, and then we are back. So do you see this cardioid? The way this cardioid goes is this way.
Did you have to draw like arrows on it?
Well, we see arrows are this way if you want the orientation of motion, right? So when you have a cardioid which looks this way, you should be so this cardioid will tell us that the limits are again negative pi over 2 to pi over 2.
How do we know that?
That's you take half of a heart.
So we're integrating in terms of y.
Right? You take half of the heart and then you will double it later. So now we have our L is equal to the integral from negative pi over 2 to pi over 2. And then we have square root of 4 plus 4 sine theta plus the derivative of this is 4 cosine theta. It is squared. Pay attention. So 4 cosine theta squared d theta. You see the squares, right? All right, good. So now we have the same the limits. So now what I have 16 plus 8 sine theta plus 16 sine squared theta plus 16 cosine squared theta d theta. Where? Oh, 4 times 4 is 16 times, yes, 32. Thank you. That's a 32 right there. Right there, 32, yes. Ah. All right. So what I'm going to do now is, again, these guys give me 16 plus 16 in front. It kicks 32 out. So I have a square root of 32, 1 plus sine theta, d theta. 32 is 2 times 16. Square root of 16 is 4, so 4 root 2. Integral of square root of 1 plus sine theta d theta. Welcome to Calculus 3. So we are supposed to solve 4 root 2 integral from negative pi over 2 to positive pi over 2 of the square root of 1 plus sine theta d theta. Now we have 3 methods to deal with this. What should conjugate? Conjugate, why not, right? So times the square root of 1 minus sine theta divided by 1 minus sine theta. that will give us 4 root 2 integral. I have on top 1 minus sine squared theta under the root, divided by square root of 1 minus sine theta, and then d theta. The top is cosine. We know that from last calculation, right? You have 1 minus sine squared gives you cosine squared. Square root of cosine squared is just cosine. So cosine theta d theta divided by 1 minus sine theta. All right, now u is equal to 1 minus sine theta. Du is equal to negative cosine theta d theta. I don't have a negative, so I have to fix that. I plug in negative out of nowhere, and then I balance it on the other side of the integral. And now I have to compute the limits. Oh, for root 2 first, negative 4 root 2. And now computing the limits. The lower limit used to be negative pi over 2. So plug in a negative pi over 2. The lower limit becomes 2. Because sine is odd function, negative pi over 2, negative jumps out, becomes a plus, and then sine of pi over 2 is 1, 1 plus 1 is 2. When you use positive pi over 2, you just get 1 minus 1, you get 0 on top. So du root u. Now, we swap these, and we lose the negative, and then this becomes u to the negative 1/2 du, and now we can integrate. So 4 root 2 u to the positive 1/2 with a 2 in front from 0 to 2. That's 4 root 2. It's 4 root 2 times 2 root 2 minus 0. So altogether 16. And now double that, it's 32. It actually didn't take 40 minutes to do it, right? Negative 1/2 plus 1 is positive 1/2, yeah.
Yes.
All right. What's next? Oh, break?
10 minutes.
All right. Let's see.